All right, today we talk about asymptotes. And if you didn't know, the theme song for asymptotes is do 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 do. Can't touch this. Do 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 do. All right, I'll stop right there. So basically an asymptote is a line or a curved line that approaches something but never touches it. So you can imagine, it's crazy to think about this blue line getting closer and closer and closer to that dotted line, keeps getting closer and closer and closer and closer forever, but never touches it. And we've got horizontal asymptotes, we've got vertical asymptotes. We do have oblique asymptotes, but we will not cover it in class. All right, let's get started. So to find horizontal asymptotes, what we do is we put our functions in standard form. And so this right here has to be in descending order, meaning like x to the 7th plus 2x to the 4th minus 3x squared plus 7. Right, see how it goes from 7 to 4 to and down to an exponent of 0. So just make sure both your numerator and the denominator are in standard form. It's time now to kind of compare your highest degree exponents. So notice how these are in yellow. We are basically taking our two highest degrees and we're comparing them. If in the numerator your number here is smaller than your number here, n is less than m, then you have a horizontal asymptote at the x-axis. If you'd like an example, that would be something like f of x is equal to a 3x to the 4th plus 2x all over 1x to the 11th plus 5. Notice here that my denominator, my m, is bigger, greater than, right, our alligator eats our bigger thing, is greater than our numerator. So since this is bigger, we have a horizontal asymptote. And the reason that's true is you can think about plugging in any big number here. And because this is x to the 4th divided by x to the 11th, x to the 11th is so much bigger. You're basically taking a small number divided by a huge number, and that gives you approaching 0. It won't get you 0, but it'll get you really close to 0, which would be that horizontal asymptote at the x-axis. All right, another case might be when your exponents are exactly the same. So for example, here we would have n and m be the same thing, and then you'd have a horizontal asymptote at a divided by b. Okay, an example of this might be a function f of x equals 2x to the 4th plus 5x cubed minus 2x plus 1 all over 3x to the 4th plus 7x squared. Notice how my x to the 4th and my x to the 4th are the same. So my horizontal asymptote is 2/3. Y equals 2/3. Keep in mind that my y equals 2/3 equation is a horizontal line. Now, if you have a case where your numerator exponent is bigger than your denominator, then there would be no horizontal asymptote. There would be an oblique or slant diagonal asymptote, but we're not doing that in this class. So here's an example. If I had something like 4x to the 7th plus 2x minus 1 all over x cubed plus 2x squared. Notice that this 7 is bigger than this 3, and so that we would basically have no asymptote. We're going to say that in this class, no asymptote, even though there might possibly be a slant or a oblique asymptote. So here's some practice. Go ahead and pause this video and see if you can figure out what the horizontal asymptote would be for each of these examples. All right, you're back. So on this case here, we have the numerator bigger than the exponent in the denominator. That would be this case, and so there would be no asymptote. Okay, for the second problem here, we have that our exponents match. So this would be a 1 divided by 1, so we have an asymptote at y equals 1. On this number 3, we also have the same exponents of x to the first and x to the first. So we would have an asymptote at y equals 1. All right, let's go ahead and run through these pretty quickly. And the first thing you should really do, and I didn't make note of that last slide, is make sure they're in standard order. So for example, make sure your cube is the highest exponent of all of these, or else you're kind of comparing the wrong things. So here I have a numerator x cubed bigger than our denominator, and so that would be case 3, that would be no asymptote. Here I have a match, so that's going to be -3/1. Or just -3. Here I have a numerator bigger than a denominator, so that's going to be no asymptote. Here I have a perfect match, so I'm going to have 1/1. Okay, here I have a numerator that is bigger exponent than my denominator, so that's a no asymptote. And lastly, we have the denominator being bigger than the numerator. That's actually a case 1, where we have a horizontal asymptote at the x-axis. Or if you want, you can call this an asymptote at y equals 0. All right, that's it for horizontal asymptotes. Next video we'll cover vertical asymptotes and holes.